Hello, I'm Dr. Mike Saville. I work in the Department of Electrical Engineering, and I appreciate you taking the time to click on the link and come and check out this video. So in this short little clip, my goal is to just teach you a little bit about what I do and a little bit about how I got to where I am. Now, that means basically, what have I done and what am I doing now? Well, I started off in Los Angeles, California, where I grew up. I enlisted in the Air Force right out of high school. And then from there, I traveled to various places across the United States and elsewhere. I quite literally saw the space shuttle launch from Cape Canaveral, Florida, and then later in my career land at Edwards Air Force Base out in California. Throughout that journey, I worked as a radar technician. One of those places took me to Honduras in the late 80s, working on this mobile radar system you see here. And that quite literally is the radar system. And later on, then I changed jobs and became a calibration technician. So I worked in a different type of facility. Typically should be humidity control, air conditioned, and all really nice, right? But I did spend about a summer during the hottest time of it in Saudi Arabia. And other jobs I've had in the Air Force, I worked as an engineer and as a professor. Now, clearly the last ones required some education. And as I said, I enlisted in the Air Force. So the Air Force, though, gave tremendous opportunity for education, and I took advantage of it. I went to Texas A&M, where I completed the Bachelor of Science in Electrical Engineering, GIGM, and then they sent me to Wright Air Force Base. It happens to be the home of the Air Force Institute of Technology, and so sure enough, I had opportunity to complete a Master's of Science there in Electrical Engineering. And then, I thought, I don't think I'm smart enough, right? Or the Air Force at least didn't agree with that, and they thought I wasn't smart enough. So, they sent me to the University of Illinois, Urbana-Champaign, and completed the PhD degree in electrical and computer engineering. I retired after about 26 years of Air Force work. I worked in the Air Force Research Lab as a civilian for about a year, and then eventually came over to Wright State in 2012, and I've been on faculty since then. I work in the Russ Engineering Center. You can see the picture here and the location. And then I teach in the electromagnetics area, remote sensing, and related technologies. But let me tell you, electrical engineering and its related technologies are the most versatile fields. I mean, just think about what your life would be like living off the grid. If you had no power, no phones, no cars, no planes, no social media. This field is always in demand, and it pays quite well. If you look at the starting salaries in our state, and especially what's in our local area, is probably even better than this. So it just goes to show you. But how do you get there? Well, faculty like myself teach you the math, the physics, and the engineering. We give you hands-on practice. Each term, you're going to find that your labs become more sophisticated. In the first and second year, you can see where you have much of the foundational math and physics, but you'll also include some basic electronics. By the end of the second year, you'll be designing, building, and proofing electric circuits. Of course, the capstone experience is senior design, typically taken in the fourth year. And that's where you'll really work on a multidisciplinary team. You'll work on a project that goes from a paper concept to a complete prototype and demonstration. In this case here, you'll see this picture with Raspberry Jam. This was a team that wanted to build a counter UAV system. As the name implies, they used a Raspberry Pi as their microprocessor. And then they were able to do some testing. And since jammers are illegal in the United States, they had to come up with some alternative methods in order to demonstrate that their electronics work, and they couldn't actually go out and actually jam a UAS, but their prototype was able to demonstrate that it would be effective. Another team here chose to design a UAV system that would allow the user to use a mobile app and define a region where it would be considered a no-fly zone. And so if the drone accidentally went there, either out of control of the user or by inadvertent use of the user, it would automatically come back to the ground. And they were successful in their demonstration. So throughout the 4 years, you're going to have ample opportunity to work in active research labs on campus, internships with local companies, national design competitions, and even local events for our radar community. In my lab, the Sensors and Signals Exploitation Lab, we explore radio and microwave technologies such as radar and artificial intelligence. The students who work in my lab are from electrical engineering, mechanical engineering, and computer science, and even physics or business majors. You know, we can all really understand the radar and how it's used in our everyday lives. I mean, if you think about it, look at the cars that you drive today. They have these collision avoidance systems on them. And, you know, this works at night. It works in heavy rain. It can help you tell if there's a bicyclist or a car in front of you. And, you know, these are areas that are emerging technologies, hot off the press, so to speak, right? So this gets us thinking, you know, using these types of technologies, what else can we do? Could we say teach the radar to read? So this is an area of interest where we're trying to set up an experiment to see if we can apply techniques that might actually be useful for other applications of interest to, say, national defense. But to understand how this works, let's take a look. What we do is we start by placing these letters. We take little reflectors and we place them in the shape of a letter in front of the radar, and we collect those signals. Now these reflectors have a particular behavior where they reflect very strongly in the direction of the radar, and so they're easy for us to identify and see. So as we process all of those signals and we form the radar images with, say, the first pulse, then the fourth echo, and after 50 echoes, you can definitely tell that this was the letter A, and you can see where those bright responses are from the target. And so then we can use an algorithm to compare what we observed to all the references, all the letters in our library, and then we make a decision about which one was the best match. And in this case, you can see certainly it matched. So, you know, how might we apply this to other problems? You know, maybe an interesting problem might be for determining which airplane is which. You know, we have planes in our lab that are very similar in model, body size, number of engines, and so forth. So this could be a problem that would be of interest, say, to the Air Force. After all, we're right next to the Air Force Research Lab, right? So let me tell you, electrical and computer engineers are always in demand, and they offer very rewarding careers. And I'd love to tell you more about our programs in electrical engineering. My information is here on the slide. It's got my email and my page. It might need a little bit of updating, but Wright State is here for you. Come see us. Come learn about our programs, our students, our faculty, or just come and learn about Raider Country. Give me a call or send me an email. I'll be glad to help you Raider up. Thank you for watching.